Welcome to today's lesson on constructions. We are going to be doing segment bisectors and perpendicular bisectors. And so the first thing that I thought we would do is define what a segment bisector is. It is something that cuts a segment into two equal pieces. And so I have here it could be a line, a segment, a ray, or a plane that will cut a segment into two equal pieces. And so I have some drawings up here that kind of represent that. And you'll notice that in order to cut it into two equal pieces, these lines, segments, and rays have to meet at the midpoint. So meet at the midpoint is kind of important. So make sure that you're paying attention to that as we go through these. And so my midpoint would be somewhere around here, and so that segment that is cut by the red ray is equal on both sides. Right here we have another segment. The red segment is cutting the black segment into two equal pieces, and so I can draw the congruent marks, but it's meeting at the midpoint there. And then I have a ray that is also cutting it into two equal pieces. Oh, going back to the segment, the one thing you might notice is it looks like it's meeting both segments are meeting at a 90-degree angle, which then steps it up to a perpendicular bisector, because the only difference between a perpendicular bisector and a segment bisector is that it meets at a 90-degree angle. And then our plane here is cutting through this segment, and if this is the midpoint that I'm coloring in green, then this segment from the midpoint to the end is the same as this point to the other end, and you'll see there's a little dotted because it's hidden behind the plane that we can't see. So this segment is the same length as that segment, and that's really what we're trying to do. So now we are going to construct a bisector, or a perpendicular bisector, and a perpendicular bisector. But the cool thing about these is they both are done the same way. So there really isn't anything that we have to do differently to get a segment bisector versus a perpendicular bisector. And when we construct it, when you construct a bisector, you are basically constructing a perpendicular bisector too. So it's kind of killing two birds with one stone, I guess, if you want to think of it that way. So the first thing you need to do is set your compass point on one of the endpoints, and then stretch the compass out so that it is over the halfway mark. And it could be well over the halfway mark. I wouldn't try to hit the halfway mark. I would go well over it. And then I swing a big arc that goes something like that. So then, and I have 100, I just keeping track of this because last time I lost my compass. So I'm going to now move my compass point to point B, the end point of B, and if I put it on point B and swing the exact same arc over here somewhere, and just make sure it crosses this arc, the second arc crosses the first arc, and I'm done with my compass now so I can remove it. Make sure the first arc and the second arc cross, then those points where they cross are where the bisector will go through. So what I'm going to do is I will draw a line from where those 2 points, I'm actually going to draw a segment from those 2 points, and where those 2 points run into those little X's would be my segment bisector. So I've just cut A and B into two equal pieces. The other thing that this new blue line has done is also cut it at a 90-degree angle. So it's a perpendicular bisector. If I move these arcs out of the way, just to move them out of the problem so you can see it, you can see that now from A to what we'll call M, which is the midpoint, is congruent to M to B. So I could write AM is congruent to MB. And so this is how we find perpendicular bisectors and segment bisectors through constructions.